Download this code from codegive.com, link in the description below. Certainly. Blender's geometry nodes is a powerful feature that allows for procedural modeling and manipulation of 3D geometry. Attributes in geometry nodes are essential for controlling and modifying various properties of the geometry, such as position, color, scale, and more. A guide to attributes fields in Blender geometry nodes. What are attributes? Attributes are data associated with geometry elements, vertices, edges, faces, in Blender. Each geometry type can have different attributes, such as position, the 3D coordinates of each vertex. Normal, the direction perpendicular to the face at each vertex. Color, the color data for shading. UV map, coordinates used for texture mapping. In geometry nodes, you can create, manipulate, and use these attributes through various nodes. Basic concepts. 1. Geometry nodes editor. This is where you create your node trees to define the geometry manipulation. 2. Attribute fields. These are fields that allow you to read from and write to attributes on geometry elements. Creating geometry nodes with attributes. Step 1. Setting up geometry nodes. 1. Open Blender and select the object you want to add geometry nodes to. 2. Go to the Modifiers tab and add a Geometry Nodes modifier. 3. Click on New to create a new node tree. Step 2. Using attribute fields. 1. Add a node. Press Shift+A to add a new node. You can start with a mesh primitive node like mesh primitive cube. 2. Add an attribute node. Use the attribute color node to modify colors or attribute position to modify the vertex positions. 3. Connect nodes. Connect nodes by dragging from the output of one node to the input of another. Example, modifying vertex positions with attributes. Let's create a simple example where we modify the vertex positions of a cube based on a sine wave function. Step 1. Create the node tree. 1. Add a cube. In the Geometry Nodes editor, start with a mesh primitive cube node. 2. Add a point scale node. This will allow us to scale the vertices based on a sine wave. 3. Add a combine XYZ node. This will help us create a new position vector for the vertices. 4. Add an attribute sample texture node. Optional for more complex effects, you can sample textures to drive the changes. Step 2. Set up the nodes. Here's a simple node setup. 1. Mesh primitive cube rightward arrow your starting geometry. 2. Point scale. Set the scale factor based on a sine function. You can use a math node set to sine and connect it to the scale input. 3. Combine XYZ. Use this to create a new vector based on the original position and the sine value. Example code representation. While Blender's geometry nodes doesn't use traditional scripting, like Python, you can represent the logic in a pseudocode style. Plain text. / pseudocode for geometry nodes setup. 1. Create a new geometry nodes modifier on the selected object. 2. Add a mesh primitive cube node. 3. Add a point scale node. 4. Create a math node and set it to sine. 5. Connect the output of the math node to the scale input of the point scale node. 6. Connect the output of the point scale node to the group output. Example node setup. 1. Mesh primitive cube rightward arrow point scale rightward arrow group output. 2. Connect the position output from the cube to the input of the point scale node. 3. Use a math node to calculate sin value, where value could be derived from the vertex position, example position.x. Final notes. Attribute fields can be used in various nodes like attribute mix, attribute transfer, and more. Experiment with different attributes and nodes to see how they affect your geometry. Remember that attributes can be created dynamically and can be transferred between different geometry types. Conclusion: understanding and utilizing attributes in Blender's geometry nodes opens up numerous possibilities for procedural modeling and effects. By manipulating attributes, you can create complex and dynamic models with ease. Keep experimenting with different nodes and attributes to fully grasp their potential.